Okay, I think it's about time for us to get started. So hopefully you're here. You might have seen the slide there. It says, Calc 11? I thought this was supposed to be Calc 2. It's Roman numerals, you know. It's like the Rocky movies, you know. That's how we learn about Roman numerals. Okay, so this class is Calculus 2. Now, Calculus 1 is about differentiation, you learn about integration. Calculus 3, which we'll take hopefully next semester, it's about going into multivariable calculus. So what is Calculus 2? Well, I call it the return of the algebra. You're going to get to do lots and lots of algebra. Now, I'm Steve Butler. I will be your host. And let me start off by saying that I'm going to try harder this semester to make the students happy. Now, last semester, I got my student evaluations back, and there were a few comments. Now, a lot of the comments were like, his test? Oh, what about his test? You know, but, well, what can I do about that? I don't know. But there was one thing I can do, and they said, he didn't do any magic tricks. Okay, so let's see if I can try a magic trick. All right. Then at least I can check that one off my list. Okay, so here is a deck of cards. All right. Let's see. We don't need any joker, so we'll take the... Okay, there's another joker. Okay, now this is a deck. This is how a deck would come if you just opened it up. Now, what you'll see here is you'll see things come in a nice order. So ace through king, and then it's ace through king in a different suit. So these are spades, these are diamonds. And then king through ace, and king through ace. You have your clubs and your hearts. Now, they do this because it's very easy to make sure all your cards are there. Okay, so if I'm going to do a trick, well, I should try to shuffle and make sure it's nice and random. Okay, so let's shuffle the deck. Now, you would think mathematics has nothing to say about things like shuffling, but in fact, mathematicians have lots of things to say about shuffling. For instance, how many times should you shuffle a deck? Well, is one enough? The answer is no, because if you just shuffle once, you'll get red cards and the black cards all together. Now, this is not because I'm great at shuffling. This would happen to anybody. So we know 1 is not enough. Okay, we definitely know 0 is not enough. So it's not 0, it's not 1. Does anybody know the answer? How many shuffles do you have to take? It's, sorry, what? 7. 7's right. 7's right. And how did we find that? Well, it's mathematicians. Now you might think, well, it's probably like the question, how many looks does it take to get to the center of a Tootsie Roll Pop? Well, 1, 2, crunch. Okay. All right. So let's see. We have to, if we want a nice random deck, we'll have to shuffle at least 7 times. Okay. So this trick takes a minute to set up, because I want to make sure that if I'm going to show you something, it's nice and random. So you don't say, oh, you're cheating. You're cheating. You're not making it random. So no, here we'll check. We've just done 4. Nice and random, perfectly random, perfectly. Well, no, because mathematics says it takes 7. Now, what do we mean? Well, it turns out that if you do less than 7, and if you're really good at paying attention, you can predict what the next card will be. So 7, whoops, doesn't want to shuffle very well today. 7's not enough. Okay, so we're almost there, and then we can get started with the trick. Okay, so here we go. I want to make sure I gotta weigh the card. Okay, that's about half and half. Okay, almost there. That was 5. Here's number 6. All right, one more shuffle, and the deck will be nice and random. Okay, so here we go. That's about half. That's about half. Make them nice and square so that they'll come together nicely. Okay, I have a nice random deck, but I like my cards like I like my calculus midterms, extra random. One more shuffle, and then we'll be ready to go. So here we go. One last shuffle, and come on, cards. You can do it. Don't be nervous. I know it's the first day. You'll be fine. And there we have a nice, perfectly random deck of cards. Okay. So, okay, I'll have to try that again some other time. All right. Anyways, let's get started with the real stuff. Now, today, it's the first day. So we have to get started by talking about policy. So hopefully you picked up a syllabus at the front of the room. And so we're going to go over the syllabus, and we'll take, I don't know, maybe 20, 30 minutes going over this because, it's good to set up the rules. And the syllabus will outline everything that you need to know. This is a big class. There's a lot of people here. So we want to make sure we all know what's going on. We're all on the same playing field. So this is Calculus 2, as it says. What's the prerequisite? You need to have done Calculus 1. But not only do you need to have done Calculus 1, you need to have passed it, which means C- or better. Now the reasoning is Calculus 2 is not easier than Calculus 1. So if you haven't passed Calculus 1, you're already in trouble, and we don't want that. Okay, so make sure you've already passed Calc 1. What's the objective? Well, we're going to continue learning about things. So things like applications of integration, more techniques of integration, you do sequences and series and parametric and polar coordinates. This will all make sense by the end of the semester. You know what all those things mean. That's what the official set of objectives are. The unofficial set of objectives is we're trying to get you to learn how to think. We want you to understand what's going on. It's not enough that you become a calculator that just takes an input and produces an output. What's going on behind the scene? What do these things represent? What do they mean? We want you to be smarter. We think that's valuable. All right. There is a textbook for this class. You do not need to bring the textbook to class. You can leave it at home. It's a heavy textbook. I believe you also can access it online. You should check. I'm the instructor, and then you have a bunch of TAs. I will say that they changed one of the TAs, so Jackie Jong will not be my TA. It's Heather Muchowski. They changed that on me at the last minute. But you have all these wonderful TAs. Their office hours here are listed as to be announced. They will be announced later this week, and I will announce those in class, and there will be an announcement online. Okay, so good news is you're here. Okay, good. So you know where the lectures are. And now, the more challenging thing is you need to find your section. So make sure you go to your section. Most of these rooms are not that big. They have just about the right number of seats. So you need to make sure you go to the section you signed up for. And with some exceptions, I think a few of these rooms are slightly bigger. But go to your section and get to know your TAs. These are nice people. They want you to succeed. Nobody's out here to make you fail. We want you to pass the class, which I guess brings us to the next topic. Now, I should say, this is usually about when people start having questions. If you have a question, feel free to ask. I know it's a big room, but that doesn't mean you can't ask. I'm happy to answer questions. So what goes into grades? Well, there's a lot that goes into your grades. There's going to be lots of tests. We're going to go over the test schedule in a few minutes. There's going to be 5 in-class tests. So we're going to take the best 4. So we drop one of the in-class tests. That'll become 30%. 20% will be the departmental midterm. And it says departmental midterm, but you really should think of it as more or less the final for the first half of the course. Because once we take the midterm, the material on the midterm will not be seen on the final. So it's sort of a semi-final, if you will. There's another final, which is called the final. That's the departmental final. That's worth another 20%. You're going to have weekly quizzes, and that'll be done in recitation. That'll be worth 20%. We'll talk about a little bit more of those in a minute. There's online homework, and the homework is done online, and we'll talk more about that. That's worth 8%. And then there's the 2%, which is very easy, which is you come and you visit me. Just come to my office, or come to my office hours, and you say, "Hey, Professor Butler, how you doing?" And you will probably respond, "Hey, I'm doing pretty good. How are you doing?" And then at this point you should say, "I want my 2%. And I'm like, "Okay, that's cool. What's your name?" And that's it. That's it. Easy. Now you probably say, "That's so easy, everyone's going to do it." No, they don't. And there are people out there who would have had a B-, but now they have a C+ because they didn't want to come say hi. It can hurt you if you're near the edge. If you're not near the edge, yeah, okay. It's okay to be antisocial. Good. No, you have to wait. You can't get your credit yet. You have to wait. There's a little dog, he wants to 2% now. You have to be patient. Okay. All right. Now, let's see. There's this note. I don't take attendance, because if I took attendance, we'd have like 10 minutes left at the end of the lecture. That's not very useful. I'm not going to take attendance. There's no clicker. There's nothing like that. You don't have to come. I want you to come. If you come, you're going to do a lot better, but you don't have to. I do encourage you to come when there's exams, but all right. Okay, let's see. Now, the cutoffs. People want to know the cutoffs. Well, if you get 90% or better, that's at least an A minus, 80% at least a B minus, and so forth and so on. Now, I put that there knowing I'm probably going to change those cutoffs, and if I do, I'll change them down. So I taught a class at UCLA a couple years ago, and I can't remember exactly, I think the cutoff for B minus might have been 45%. So if you got a 45%, you were B minus. That was a challenging class. It was fun. It was fun. I like that. It's probably not going to be that. I've mellowed out. I've gotten soft in my older age. So probably more like 70% will be a cutoff for a B minus here. But anyways, just know, don't panic. People think I'm a nice person until they see the test, and then they get really, really nervous about their grades. Don't worry about it. We'll adjust. We'll adjust. Now, there is something you should be aware of. This is a very important paragraph. If you have any issues about grading, it's perfectly fine to come talk to us and say, I think there was something wrong in how this was graded. Fantastic, let's look at it. But you have to come and talk to us within 2 weeks. If you wait for longer than 2 weeks, no, sorry, you waited too long, can't look at it anymore. So make sure you look at it, and look at it right away. Now the reason we're doing this is we're trying to encourage you to say, look, it's important to figure out what you did wrong. What were your mistakes? And you should know what your mistakes are. It's uncomfortable to see your answers and to like, oh my gosh, I can't believe how terrible that mistake was. But you need to see it. And you need to realize, okay, I made that stupid mistake. I will never, never make that mistake again. And the good news is there's plenty of other mistakes you can make, so don't feel bad. But don't keep making the same mistakes over and over again. It's like that song from Zootopia. I'll keep on making those new mistakes every day. New mistakes. It's all right. But the same mistakes, that's terrible. Now, the other thing here is, look, if you don't want to pick up your quizzes or exams, that's okay. Don't pick them up. But if you don't pick them up, that tells us you don't want them. And if you don't want them, that means you want 0. So if you do not pick up your exams and your quizzes by the end of the semester, we will re-enter those scores as 0s. And we do that. There are people who are walking around with a C who would have had a B+. They didn't come and pick it up. Now, I'm not trying to scare you. I'm just trying to say, don't do that. Just look at your stuff. Look at your work. All right. Any questions about grades? I'm sorry, I'm making you nervous. Now you're like, oh my gosh, he wants to... No. Okay. All right, okay. So this is all fairly clear. Good. Let's talk about homework. Homework will be done online. You should automatically be enrolled. You will not need a course ID number from me. If it's asking for a course ID number, something is wrong. Go to Blackboard, log in to Blackboard, go to course content, and there should be a link to My Math Lab, and that will take you to your homework. You can start homework 1 today. Now, that's the only homework you can start. Basically, every week a new homework comes out. There are 14 homework assignments. We drop, how many do we drop? 6. So we drop 6. Well, what does that mean? Well, stuff happens. And it's amazing how many computers have technical failures on Friday at midnight, which is when the homeworks are due. And so, okay, so if you had a technical failure, that's one of the ones that we drop. It's very unlikely that you're going to have more than 8 technical failures at midnight on a Friday. So that's good. The other thing is, if you're doing the homework and you're like, I don't feel like I'm getting much out of it, do the first 8 and stop. You'll get full points. But at least try. Okay, so let's move on to quizzes. There are 13 quizzes. They'll be given during your recitation. How do we do quizzes? Well, quizzes are a little bit different here. So maybe I should skip ahead. So your first quiz, by the way, is tomorrow. Now, if you look at the next page of the packet, you'll see that there's this review sheet which does algebra and trig and so forth and so on. And on the back of this review sheet, you keep reading, oh my gosh, look at all this cool stuff that we're expected to remember. But then it says the following: Quiz 1, Problem Bank. So each quiz is going to have something like this, where there's the review sheet. These are the things that we were talking about this week, things you should be aware of, basic formula, and a problem bank. And that problem bank will have at most 10 questions. And here's how the quizzes work. Each recitation, there will be randomly chosen by a computer 2 questions from this set of 10, and those will be your questions. We will not change one number, we will not change one symbol. These will be exactly the questions that you might see. So if you can do these 10 problems, then you're good to go. So it gives you something to work on. So I suggest tonight, and maybe tomorrow, that you work on these problems. Now, how can you prepare? Well, you can prepare in groups, but you can also come and talk to me, you can talk to the TAs. In recitation, the first 35 minutes, you can ask the TAs anything you want. In fact, you can say, look, how do I do number 5? Well, let's see what's number 5. Oh, that's a fun one. Anyways, so but ask them, and they'll talk about how you do number 5. And you can come to me, and you can ask me. One thing I didn't mention is that if you look at me, it says here, I have super happy fun calculus hours. That's the time that you can come and ask me stuff. Okay, how do we do these things? Now, I've scheduled them early in the week just because I know students don't like to think about things more than 24 hours in advance. Okay, so I'll have office hours today, 3 to 5, and tomorrow morning starting at 7 a.m. because there are people who have recitation at 8 a.m. So I'll have office hours from 7 to 10 tomorrow morning and 11:30 to 1. You can come to office hours, get a question answered, and take care of that 2% right away. So anyways, all right, lots of ways to get quizzes answered. There's exams. There'll be 5 in-class exams, and the dates are scheduled. We'll go over the whole calendar in just a minute, and a departmental midterm, and the final, and all exams are closed book and closed notes. Exams have to be taken at the scheduled times. We do allow things, for example, for medical emergencies. For instance, if your appendix has an unfortunate scheduling issue, we will let you take a makeup. And there's other issues involved. Now, here's an important topic. Calculators. Well, you probably have really beautiful, powerful calculators out there. You don't get to use them for the quizzes. But you can use a calculator like this. Look at it. It's beautiful. It's simplicity. It's elegant lines. And its lack of buttons. It's a nice calculator. So you can use a calculator that can do arithmetic. So add and multiply. No quiz problem, no exam problem, no midterm or final problem requires the use of a calculator. But some people are uncomfortable doing arithmetic, which is, I'm okay. Here's something you can use to do arithmetic. So these are the type of calculators you can use. If you don't own such a calculator, you can buy them at Walmart for, I think, $1.50. If you cannot afford $1.50, come talk to me. I have a calculator I can let you borrow. In fact, I have a whole bunch. So those are what are allowed. Now there's a little note that says the departmental midterm and departmental final might have a different calculator policy, and they do. On the midterm and the final, you are allowed your really expensive calculators, your scientific calculators, your graphing calculators. Do you need those? The answer is no. Again, a basic calculator is all you need. Now, how do I know that? Well, I have connections. I know who's writing the midterm and who's writing the final. And I know that they love these kinds of calculators. And so they will definitely make sure that's all you need. All right. Now at this point, we would normally have a nice interlude, and you could stop listening to me and listen to an SI person. SI is supplemental instruction. Normally we would do that. However, there is a shortage of SI people as far as I can tell, and they didn't have enough SI people for all the large lectures. So we don't have an SI person specifically for this section. Now there are SI people for other sections of Calculus too. You can go online to the website and you can explore that option. They will run more or less along the same lines as we do because there's not really much of an option. Given how many sections we have to cover, we almost all go at the same speed. It's not going to be exactly the same, but it's another option for you to look into. And that's all I have to say about SI. For accommodations, if you have any needs or special accommodations, please come see me as soon as possible. Even if you haven't filled out the form yet, at least let me be aware that you are filling out the form. We can help you in the meantime. It's really important, and it helps us for when we're scheduling midterms and exams. Cheating is stupid. If you cheat, you will lose the ability to add the numbers 5 and 7, and you will believe for the rest of your life that the a plus b squared is a squared plus b squared. And you're probably thinking, wait, why is that bad? Isn't that true? You've already lost that ability. Okay, no. All right. It's not true. It's not true. Cheating is bad, but I mean, I know it's when you're in a stressful situation and you're going to feel stressed. You're going to probably at some point feel like you're being pushed beyond your breaking point. And there's a reason you're going to feel that way, because we're going to try to push you beyond your breaking point. But we're doing that so you can see where you are and understand how you're doing, not because we're trying to make you feel bad. So you're stressed, and it's understandable. You don't need to cheat. I mean, just work hard. You should get the grade that you need. And is there a good moral argument for advocating not cheating? I don't know. There probably is. But you know, the person that you're going to become is going to be determined by your actions. So become someone who doesn't cheat. Become someone who works hard. Hard work is way more effective, and no one ever throws you out of a class for working hard. Now, the last thing on the syllabus is that we have a course website. I put some announcements on Blackboard, not very many. Most of them will be, here's some advice, here are things coming up, and here's a link to the course website. Now at the course website, you will find things such as the following: a copy of the syllabus, the quiz problems, and they will be posted at least a week in advance. Right now you have the quiz problems for 1 and 2 in your hand. Quiz 3 will be written this weekend. That will be posted online. You will find copies of old exams and copies of practice exams as they've been written. And eventually, you will also find links to copies of the slides. So anything I put on the document camera will be scanned in online. And assuming that technology is friendly to me, I will also try to record the lectures in some way, and I will post those online as well. So you will have lots and lots of material. All right. So I think the only other thing I want to go over, now that our class is halfway done, is the schedule. So you have a copy of the schedule. Everything has been planned. So a couple of things that are important are things such as the test. So for example, January 30th is a test. Okay, good to know that. That's here in this room. February 17th, that's your next test. When's your test after that? March 10th, right before you take your spring break. Okay, that's not a bad time to take a test. And then you're going to have, April 5th and April 21st. So those are dates you should be aware of. April 5th, April 21st. Okay, some other very important dates I want to draw your attention to is Thursday, February 23rd is the departmental midterm. That does not happen in this room, maybe, I don't know. It will happen somewhere. It also happens at 8:15 at night, which, given that we have a 9 a.m. class, is probably going to be pretty tough for some people. But you need to be aware of that and make sure you plan accordingly. The good news is, the day after, February 24th, there's no class. So you get that day off so you can recover from the midterm. Now the last thing I want to draw your attention to on the calendar, is this. This is finals week. Now you'll notice I spell out the word final, but I spread it over 5 days. Why have I done that? We don't know when the final will be yet. You see, we are a group final. One consequence of that is that group finals do not get scheduled until a few weeks before the final exam happens. Do not make any travel plans before May 5th, late evening, until you know when the final is scheduled. Because, unfortunately, I have this really cheap ticket and I bought it, and then I found out my final was scheduled for the next day. You're out of luck. You're just going to have to eat the price of the ticket. That's not a reason for you to reschedule the final. So do not make any travel plans until you know when the final is over. Nobody's asked me any questions yet. I feel like, have I been unusually clear? Oh, there's a, great, yes, please.
You talked about under the quizzes,
Yes.
posting answers to the quiz problems before the
Oh, you want to know about the answers, so that someone was asking. You said under the quizzes that you post the answers. You see, I want people to do well on the quizzes, and so if you go to Carver Hall in 3 locations, you will see the questions listed, hints for each question, or maybe suggestions are a better word, and then the final answer. Now, the final answer just means what's the final number you do. It doesn't show you all the intermediate steps. So where can you find that? You can find that outside my office. I'm in Carver 400C. It's really easy to get to. Go into Carver. Go to the elevator. Go to the 4th floor. Get out of the elevator, you look across the hall, you'll see a bunch of glass. That's Carver 400. You go into that room. There's one office there. That's Carver 400C. That's my office. So that's one place it will be listed. Second place it will be listed, or you can find them, is Carver 101. There's the lobby there. That's where if you go to Cyclone Cinema, on that big lobby, there's 2 big bulletin boards. One of them is full of stuff and it's very highly disorganized. The other one is almost barren. The barren one is the math department. Okay. But on that barren one, you will see copies of the quiz problems and the answers. The last place is in Carver 385, which was the former location of the math help room before they stopped doing math help room. But that's also where my office hours are on Tuesday morning. So that's where you can go look for them. And I also am sending more detailed answers to the TAs. The way that the math department does help now is that any TA for Calc2, and there's about a dozen of them, not just our 4 TAs, but any TA for any section, post office hours, and you can go to any one that you like. So if you want, you can start shopping around. Okay, let's go to a TA. Okay, give them a hard problem and see how they do. Oh, can't do it? Okay, let me try the next one. Look for a good, that sounds mean, doesn't it? Okay. Give them an interesting problem. Give them a fun problem and see if they make it fun, But look around, There's a truth that different people explain mathematics differently, and so as a consequence, no one person is good for everybody. You might like the way I teach mathematics. Other people hate the way I teach mathematics. And I'm okay with that. Just find someone who you understand and you like. Great question. All right. Any other questions? Okay. Then in our last 20 minutes, we will get to today's topic. Now, what's today's topic? Well, it says syllabus, but really we want to talk about calculus. Now, some general advice. First off, I like to throw this pie chart here, and then when I drew this pie chart, it sort of occurred to me that if I just turned it a little bit here and added an eye, it becomes like a Pac-Man. But anyways, a pie chart. Why do people struggle in calculus classes? And people do struggle a lot. I've been teaching calculus more or less for maybe 20 years now, working with students. And this is my experience. If I divide things into 2 parts, the calculus part, the actual calculus part, is actually not the reason why students struggle. Because the calculus part is beautiful. And it's a very elegant ideas, and they know the rules, and they know how the rules should be applied. So where do they struggle? Well, they struggle in the very hard things of copying numbers down correctly, doing addition and subtraction, arithmetic, doing algebra, doing trigonometry. It's your basics. That's where people struggle. And when I say copying, I really mean that people will, you can see them on their test. I remember I was grading a test last semester, and the answer was supposed to be a 4. And on one line they had a 4. And on 4 lines down, it was clearly a 9. And you could see from line to line as it slowly morphed from a 4 into a 9. You're just like, that's amazing. That's really cool. They have to lose points for that, but it's amazing. You know, so just make sure you copy things down right, and that'll help. Okay, some general advice on how to do well. If you've been onto Blackboard and saw this, you'll probably recognize most of these things. So come to class. I know we don't require attendance, and you can say, oh, he posts things online, I don't need to come. But you should come to class. You should listen. You should take notes. I taught 2 different types of lectures last semester for Calc1. One was a large lecture, not quite as large as this, but it was a large lecture. One was a small class, about 1/4 of the size. At the end of the class, the large lecture did pretty well in the final. They were a little bit above the departmental average. I think they were around 53 or 54. The small class was around 65. Now, where did that bump come from? I'll tell you the big difference. It's not because they were in a small class. It's because I had almost perfect attendance the whole semester. They came. They came to every class. They listened, and they'd ask questions. And not only did they come to class, they'd come to office hours. I had 7:30 a.m. office hours. Half the class showed up to those office hours, and they worked. You can do this. You can do this. You can come to the lecture. You can ask questions. You can go to office hours. And if you do that, it'll bump up your grade. A 15% bump on the final, that helps a lot. So come to class. Do as many problems as you can. The harder, the better. And there's a little note. The first 1,000 are always the hardest. And then after that, it gets a little bit easier. So it helps to do hard problems. You should challenge yourself. You don't get strong by lifting 1-pound dumbbells. You got to get heavier dumbbells. You want to be lifting, by the end of the semester, you want to be lifting those 100-pound dumbbell problems. It's like, yeah, I can do these harder problems. You want to get better. It's okay to struggle, and it's okay to make mistakes. It happens to everybody. It happens to me. I struggle. There's still a lot of mathematics I don't know. And I still make mistakes. I hopefully make fewer mistakes, but it's okay. The thing is, learn from your mistakes. That's why we want you to take these exams. The exams serve 2 purposes. First off, it lets us know how you're doing, but second off, it lets you know how are you doing. Where are you making your mistakes? So it's okay. It's not okay to give up. Okay, ask for help. Ask for help. There's this tendency for people not to ask. I think that maybe there's a stigma against it. It's like it's a shameful thing to not be able to answer something. Get over it. It's not very helpful advice because it's not very easy to do, but you need to get over it. Yes, high school and college are different, and it's intimidating. You're in this large room, you feel like, the professor doesn't care if I come and ask. Why? I don't feel comfortable doing it. I don't mind. Go ahead. Come and ask. I may not be able to offer you much, but I'll do the best that I can. But it's important that you do it as soon as you need. Don't wait until the last week of the class and say, I haven't done anything yet. I can't help you. All right. Focus on the small stuff. And it's almost all small stuff. It's those details. The details. If you get the details right, the rest of it just works out. And if you see a big problem, don't think of it, oh my gosh, this is a big problem. Think of it, how can I break this into smaller problems? Understand each one of those and working on it. And the last thing, which I don't know, yes, believe you can change. A lot of people think, okay, I am who I am. I'm never going to change. the level of math that I can do today, that's it. I've reached my predetermined level. I'm never going to get better. That's not true. You can get better. Everybody can get better. But if you go into the class with the mindset, okay, look, I already know Calc 2. I can't learn anything new. Why bother? You're never going to get better. You have to open yourself up to the possibility that you can get better. All right. Now, let's do a very short course on calculus. This is very short in that it's just one page. All right, so here we go. Well, we understand flat things well. Okay, I can believe that. What do I mean by flat things? Well, you have lines, rectangles, three-dimensional boxes, planes. Oh, whoops, sorry, wrong kind of plane. Sorry. Okay, I mean plane like a flat piece of paper kind of plane. Sorry. Typo. See, I make mistakes. It's all right. Okay, so we understand flat things very well. All right, we're good with flat. That's the first thing that we know. Now here's the catch. The world is not flat. We don't see a straight line. We see squiggly things. We don't see boxes and squares. We see blobs. We don't see planes. We see surfaces. Okay, so now here's the conundrum. The things that we understand are not the things that we have to deal with. So here's the basic punchline. We approximate things which are not flat by things which are flat. That's calculus. This is what calculus is built off of, is this idea. Let's approximate things which are not flat by things which are flat. Okay. So let's give an example. Now, calculus has two sides to it. The first side is what's called differential calculus. Now, differential calculus, at its heart, asks a simple question. It asks the following. How is something changing? So I have this function, and it's moving up and down, oscillating in some pattern, and I want to know, how is it changing? Well, let me be more precise, because I can say, well, it depends where you're at, because in some places it's going up, in some places it's going down. It varies, which is the right answer. But I'll rephrase it. How is it changing right here? What's going on right there? You say, well, it's wiggly, but what I can do, I can pull out my microscope. Or if you like, your magnifying glass, something, and zoom in. So if I zoom in, and I see that, yes, it's very wiggly, but when I zoom in closer, I see something like this. And there's less wiggle. The wiggle has gone away. But it's not been completely gone. So I say, okay, no problem. What we can do is we'll just up the power. Better microscope. Okay. So we zoom in. And now if we zoom in, what do we see? Well, we see something kind of like this, where there's a bend, a bit of a bend, but it's really looking a lot more flat. Not perfectly flat. You say, okay, can we do better? And the answer is yes. So we pull out our scanning electron microscopes. We go over to physics and we say, we really need to zoom in on this thing. They say, no problem. And so you zoom in even closer. And after you keep zooming in for a long time, then what you'll end up with is you'll end up with something which is imperceptibly different from a straight line. It looks flat. Now, why do we do this? Well, it's flat. Remember, we understand flat things really well. And so if I ask for what's the rate of change of a flat thing, there's an easy answer to that. The rate of change, that's the rise over the run, change in y over change in x, also known as the slope. I know how to find the slope of a line. So I can approximate locally, say my function looks like a line, so I can talk about its rate of change by finding the slope of that line. That's differential calculus. That's the idea. Now you might say, okay, that's a nice philosophy, but at some point you had to say, well, I zoom in, I zoom in, I zoom in. So how do you know how far you have to zoom? I mean, Do we need to be close? Do we need to be very close? Do we need to be very, very close? In general, the answer is, well, we need to be very, 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 very close. Really close. How do you do that? Well, the answer is limits. Limits, students are like, ugh, limits are terrible. But let's think about the idea of limits. Limits are really beautiful. See, the basic idea of limits is simple. We're trying to understand what should happen. Now there's an important word there, should. And how do we know what should happen? Well, we say, well, what's happening nearby? So we look at the behavior of the function, and we look at what it's doing. We say, well, based on what this function is doing, here's what should happen. So that's what a limit does. And derivatives are now, we can talk about this in terms of limits. So a derivative, which we denote with a prime symbol, f prime of x, that's a limit here of f of x plus h minus f of x over h. Now, this right here, this is a slope. This is the slope of the secant line. So since it's a slope, well, that's easy to define. The top is a rise, the bottom is a run. And then we say, okay, well, that's the slope of a secant line. I want the slope of a tangent line. So what I'm doing is I'm looking at what are the slopes of my secant line as I'm getting close to where my tangent line will be. That's what this limit is doing. What will my slopes become? Now, the good news is, okay, conceptually it makes sense. We have a way to do it. The bad news is it's really, really, really hard to work with limits all the time. So we don't. Instead, what we do is we build up a library of rules. And if we have a collection of rules and basic ideas, we can take any derivative that we want. So we need to know more or less two things. First off, we need to know what are our basic derivatives. So here's the basic derivatives that you should know. This is something that you should recognize. The derivative of x to the n is nx to the n minus 1. Derivative of log x is 1 over x. Derivative of e to the x is e to the x. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of secant is secant times tangent. And my favorite one. I know math professors are not supposed to have favorites, but I do. I do. It's this one right here. You're so beautiful, arctangent. The derivative of arctangent is 1 over 1 plus x squared. Ah, it's fantastic. The last time I taught Calc 2, mind you, it was a while ago, so this was almost 15 years ago that I taught Calc 2. Every single test, we had 7, it was a really strange class, we had an arctangent function. By the end of that class, students had a very strange relationship with the arctangent function. I really hope they came to love it like I do, but anyways, it's hard to say. It's hard to say. Okay, so those are our building blocks, but we also have to have rules for combining. There's 3 important rules. You're probably saying, I thought there was more than that, but no, there's 3 important ones. What are they? Well, the first fact is that derivatives are linear. If you're taking the derivative of a sum, just take the derivative of each one individually. If you want to multiply, just bring the constant out. So that's the first one. Linear is just a fancy way of saying addition and scaling is easy to work with. The second nice fact is the product rule. So if I have the derivative of 2 things multiplying, there's a rule for that. The derivative of f of x times g of x is f prime times g plus f times g prime. The third important rule is the chain rule. Chain rule is just a way of saying a function inside a function. So if you ever see a function inside a function, think chain rule. The derivative is the derivative of the outside, plug the inside in, then multiply on the outside by the derivative of the inside function. F prime of g of x times g prime of x. These are the 3 important rules. And we will see these 3 important rules show up when we go on to the second part, which is integration. The quotient rule follows from rules 2 and 3. I can memorize the quotient rule, but it's not that important. The derivative of inverses, I don't think we'll use that, but I'll write it down just in case. I don't expect you to memorize that one either, but I do expect you to know these first 3. All right. What are applications of derivatives? There's 2 important ones. First one is optimization, such as finding max and min. That was what we covered in Calc 1. I don't think we will do that much in Calc 2, if at all. You will see it again in Calc 3. The second application is approximation. because we have this philosophy that, look, if we zoom in, we look like a flat line. So if we come back to this example, if I zoom in, I look like a flat line. Now you're probably saying, well, didn't we master this art of approximation? Yes, but what if we didn't zoom in quite so much? And we came back and said, this is interesting. It's a little bit bendy. Maybe instead of using a line, I can use a parabola? Get a better approximation? Oh, that's a good idea. We'll get to that in the second part of the course. All right. Last comment about derivatives. Derivatives are very mechanical. That is to say, they're very boring. Once you've mastered the rules and you know the basic functions, there's not really much thought that has to go into it. You can just take any derivative that you want. Just follow the rules and you'll be fine. And so derivatives, they're not the most exciting thing. Okay, now let's go to the second half of the course. Now, differential calculus, remember, asks the question, how is something changing? Integral calculus asks a different question. What's the total? How much is there? Now, oftentimes, a lot of people say, well, integral calculus, that's when we find areas. And the answer is no, it's a little bit more than that. It's true that you can use integral calculus to find areas, or I should say, well, yeah, to find areas. And that's how we think of it, but in fact, integral calculus, as we're about to see in the next 3 weeks, has lots of applications. Anytime you want to ask the question, how much is there, that is an integral calculus question. Now, how do we answer that question? Well, let's phrase everything in terms of area. What's a flat thing that we know really well and can find the area of? Someone said rectangles. Actually, they said rectangles, but I heard them, and I'm going to say it louder for them. They said rectangles. That's right. We know how to find areas of rectangles. So what we want to do is to say, well, look, let's make it look like a bunch of rectangles. And the philosophy is very simple. We just say, okay, take what we're finding, and we're going to cut it into these thin strips. Now, why thin strips? Well, because each thin strip looks like a very tall, skinny rectangle, but not perfect. The top is a little bit rounded, but I can approximate each one of these by a rectangle. And I say, well, look, if I approximate each one of these by a rectangle, I can find the area of these rectangles. I add them up. That's not a bad guess. What's a better guess? How do I do it? Trapezoids. Oh, that's not. You're thinking. Oh, yeah. We'll get there. We'll get there. But what else can I do? Smaller rectangles. More chopping. If I chop into smaller parts, I have more things to add together, but the error is smaller. It's a better approximation. How do I get an even better approximation? Even smaller rectangles. That's the right. That's the idea. So exactly. So here's the basic idea behind integral calculus. We're looking for something. So what we're going to do is we're going to take what we're looking for and we're going to chop it into lots of little tiny parts. But we're going to do it in a smart way. And by smart, I mean we're going to do it little tiny parts where each part we understand well. Okay, so we understand each part really well. For each part, we give a good approximation, and then we add them all together. Now, if we want the exact result, well, make the parts smaller and smaller. So you'll see that we have this basic idea. We have the adding together. We have the approximation to each part, so that's a height times a small width. That's the area of one rectangle. And if I say, well, what's the result when I put them, the limit as they get smaller and smaller? In other words, I'm taking a limit here. It's what we call an integral. The integral from a to b of f of x dx. Now, there are some basic rules. Things such as, the integral from a to a is 0. The integral from a to b of f of x dx is negative the integral from b to a of f of x dx, which says that our line has an orientation, and there's some others. But looking at the time, I can see our time is up, so we'll pick up here next time and go into our first interesting application. If you didn't pick up a syllabus, they are here at the front of the class, and I will see you on Wednesday.